Welcome to another video in our video series called THINKSIX, where we discuss trends and aspects of what may become the next generation in wireless communication and will eventually be called 6G. In our first video, we explored the potential timeline for 6G from a standardization and regulatory perspective. We concluded that 6G may hit the ground between 2028 and 2030. Meanwhile, several other industry players published their views and vision for 6G, confirming the initial timeline we discussed on this channel a while back. In some publications and marketing collateral, you can find also information on spectrum for 6G and that it uses sub-THz and THz frequencies. Sometimes it sounds that there are decisions and regulations already in place and that specific frequency ranges are assigned to this next generation wireless communication standard. In this video, we will provide an overview on the current regulation for the higher frequencies beyond 100 GHz, clarify the situation on spectrum made available for 5G new radio, its evolution, and what's going on in terms of 6G. At the end of this video, you will have a complete understanding that there is no spectrum assigned for 6G just yet, but that fundamental research is carried out by academia and key industry players to gain more experience with frequencies beyond 100 GHz. Let's get started. First, let's have a look at the spectrum landscape for 5G new radio. As many of you know, 5G NR is defined for two frequency ranges, FR1 and FR2. For 3GPP releases 15 and 16, frequency range 2 ends at 52.6 GHz. At the most recent World Radio Conference, hosted by the ITU in November 2019, several frequency ranges were confirmed on a global scale and made available for IMT 2020 systems, which are commonly called 5G. Some of these ranges are already available as frequency bands in 3GPP. Some, like the 47 GHz band, are about to be added to the specification. In this case, it will be band N262. For the next World Radio Conference in 2023, additional spectrum is under discussion for 5G. In particular, the 6 GHz band. There are regional differences. In some countries, the frequency range is intended for unlicensed use, whereas other countries are still debating the use of it based on a licensed model. 3GPP, as a standardization organization, is addressing the different use of the spectrum via two technology components. For licensed use of the 6 GHz band, there is standard 5G new radio. 3GPP Release 16 defines new radio and unlicensed spectrum, short NRU, which can be used to access the 6 GHz in the regions where it is defined as unlicensed frequency band. Due to that flexibility, two additional frequency bands are under discussion in 3GPP's working group RAN 4. That's band N96 and band N97 that are about to be added to the specification as well. 3GPP discussed for the evolution of 5G an extension for supported spectrum and captured results in two separate technical reports. First, what I call here FR3, which addresses the gap between 7.125 and 24.25 GHz. Second, frequency range 4, from 52.6 GHz up to 114.25 GHz, where some companies even propose a frequency range 5 that addresses spectrum all the way up to 275 GHz. Especially frequency range 4 was discussed, and ultimately a frequency extension for FR2 up to 71 GHz is added for 3GPP Release 17, where the required work is supposed to be finished by December 2021. Originally, the FCC made the frequencies between 64 to 71 GHz available as an unlicensed frequency band in the United States back in June 2016. Meanwhile, that spectrum was approved globally at the recent World Radio Conference 2019 and first adopted by 3GPP. In some literature, this extension is called FR2+. So in summary, this is the spectrum that is supported by 3GPP's 5G new radio standard. What about spectrum for beyond 5G and 6G research? Is 6G only targeting higher frequencies? At this point in time, we can assume that a 6G standard is not designed to only target spectrum beyond the spectrum that 5G supports today. Also, 5G was never intended to only support millimeter wave frequencies. It always targeted sub-6 GHz spectrum as well. The same can be expected from 6G, however, 6G may go beyond what 5G is supporting today. Some applications require wider bandwidths on what 5G is supporting today, especially if we consider sensing and environmental awareness as one of the key application areas for a 6G standard. So what's the status on higher frequencies from a regulatory point of view? Well, there are regulatory initiatives to open up spectrum beyond 95 GHz and make it more accessible by academia and industry. For instance, the Federal Communications Commission in the United States has an initiative called Spectrum Horizons, where it plans to grant access to the spectrum between 95 GHz and 3 THz via experimental licenses that are lasting up to 10 years. Also, the ITU targets this frequency range, in the beginning focusing on 275 GHz to 450 GHz. The industry is supporting such initiatives with industry alliances such as the Millimeter Wave Coalition. At the moment, there's also only one standard defined targeting this particular frequency range. That is IEEE's 802.15.3D-2017 standard for wireless short-range communication. It's largely based on WiGig, so on 802.11ad and AY standard, but has not yet gained any industry relevance, because it's not just that trivial to reach that frequency range with a wireless transceiver. As of today, there are no spectrum allocations beyond 275 GHz anyway. So it's a new frontier, not only for the industry, but also for regulators. To gain experience in this sub-THz frequency range, academia and some industry players announced their work in, for instance, D-band or G-band. However, it is not spectrum that's officially assigned to 6G. It is in the reach of the industry, low-hanging fruits, if you like. It is spectrum that can be addressed by today's technology when mastering certain challenges, and therefore marks an ideal candidate for fundamental research. Let's take a closer look at D-band, as it is often cited in scientific publications when it's about 6G. The D-band spans the frequency range from 110 to 170 GHz. This 60 GHz of bandwidth that the D-band offers are not freely accessible. In fact, there are global radio regulations in place that prohibit any radio emissions in specific parts of the frequency band. These parts are highlighted here in red. Other parts of the spectrum are used by different applications. The table provides an overview and lists the related regulations of the ITU and the FCC. If we put it all together, then we can see there are some chunks of spectrum that could be used for wireless communication, either for fixed services such as front or backhaul, or for mobile services. In total, these are 27.2 GHz of bandwidth. However, the widest individual block offers 7.5 GHz of bandwidth. To create wider data pipes, the aggregation of component carriers is required, as it was required for 4G LTE and 5G New Radio. Wider carriers, say 10 GHz or 20 GHz of bandwidth, require a change in regulation, which is a long and complex process. That raises the question when such a change in regulation could be discussed and agreed upon, and when in general new spectrum can be assigned for wireless communication. Well, that's the responsibility of the ITU, and the forum for doing this are the World Radio Conferences. The ITU allocates spectrum not to a specific generation of wireless communication. The spectrum is assigned for systems and standards that meet certain criteria. These criteria are defined by a technical group within the ITU that is called International Mobile Telephony, short IMT. Initially called IMT 2000, then IMT Advanced, and now IMT 2020. IMT 2020 systems are more commonly understood as 5G. And the ITU already started to work on a report for future technology trends and requirements for so-called IMT 2020 and beyond systems, which are likely to become 6G. Based on the current milestones and timeline, The next opportunity now to identify potential spectrum for IMT 2020 and beyond systems are the World Radio Conferences in 2023 and 2027. So how can we summarize what we just learned? Well, we can conclude that today, late 2020, there's no spectrum officially assigned to what may become a 6G standard. International regulation puts a first emphasis on the frequency range between 275 and 450 GHz. There's only one standard targeting spectrum in this frequency range today, which is IEEE's 802.15.3D-2017, which has no industry relevance as of now. The majority of today's scientific publications around 6G focuses on D-band, potentially G-band. However, both frequencies are not officially 6G spectrum. The work is carried out based on experimental licenses granted locally by the respective regulator. This is fundamental research to develop a better understanding on how to use frequencies beyond 100 GHz for wireless communication. Taking the D-band from 110 to 170 GHz as an example, based on today's regulation, wider signal bandwidths, as in 5G with today's maximum 400 MHz per component carrier and total aggregated bandwidth of 1 GHz, are definitely possible. However, bandwidths of 10 GHz or more per carrier are not supported from a regulatory perspective. Therefore, it is very likely that also in 6G we will see a form of carrier aggregation to enable high-speed data for short-range wireless communication. Nonetheless, the frequencies beyond 100 GHz are of high interest to the wireless industry, and Rohde and Schwarz supports this interest with its innovative test and measurement solutions. But this is a topic for another video in our new video series called THINKSIX.